two continents believe they are building the semiconductor future. Both passed CHIPS Act. Both promised billions. But only one is actually moving fast enough to shape the next decade of AI and national power. What happens when America treats chips like a strategic weapon and Europe treats them like a negotiation? Let's break it down. Welcome back to Chips Weekly by Diana. And today we are diving into what will define the digital world for the decades. The American CHIPS Act versus the European CHIPS Act. They were born from the same crisis, the global chip shortage. But the execution has gone in two completely different directions. One has become an engine for the construction of the new fabs, attracting global giants and securing the world's most advanced nodes. The other one is struggling to turn ambition into reality within a political system built on compromise and slow consensus. This episode isn't about comparing policy documents. It's about understanding why two strategies launched with similar goals produce such two different trajectories. So let's start in the United States. The United States CHIPS Act is speed, scale, and silicon power. The United States didn't just launch a funding program. It's launched a national project. When the CHIPS Act passed, the United States immediately began funneling money into shovels, concrete, steel, and construction permits. Within months, you could see physically new fabs rising out of the ground in Arizona, Texas, Ohio, and New York. TSMC didn't wait. Intel didn't wait. Samsung didn't wait. And also Micron didn't wait. America's strategy is intensively focused. Bring the world's most advanced chip making back onto US soil and make it impossible for your future AI hardware to exit without American capacity. But America didn't stop at the building fabs. It built the ecosystem around them. Advanced packaging centers, workforce pipelines, university programs, and new domestic suppliers for chemicals, gases, and silicon materials. And then there is geopolitical piece. The US didn't hesitate to use export controls to reshape the supply chains far beyond its borders. Lithography tools, EDA software, chip-making technology. America leveraged its technical influence to determine where advanced chips could and could not be made. Its industrial policy wrapped inside national security, powered by extraordinary urgency. So now let's come to the Europe's CHIPS Act, ambition that meets fragmentation. Europe's CHIPS Act was a launch with impressive goals, doubling Europe's market share and advanced manufacturing on the continent. On a paper, looks bold. In reality, it faces a structural challenge that the US doesn't. Europe is not one country. It's 27. That means 27 sets of approvals, 27 political priorities, 27 budget cycles, and 27 industrial ambitions that don't always align. So Germany focuses on attracting mega fabs. France prioritizes R&D excellence. Italy and Spain push for incentives. And Netherlands leans on its equipment strengths. Poland and Czech Republic compete for new projects. And Brussels try to coordinate. But coordination is not the same as unified action. This creates delay. Projects that would break ground in months in the US often take years of negotiations in Europe. Europe doesn't have significant progress. So Intel's planned mega project in Magdeburg, TSMC's Dresden venture, ST Microelectronics and Global Foundries in France. But Europe also faces a deeper problem. It doesn't control many of the things its fabs will need. So now coming to two chip acts and two philosophies. When we look closely, the divergence becomes even clearer. The US is moving with a single purpose: build cutting-edge fabs, support AI hardware, secure advanced manufacturing, and dominate the technologies of the 2030s. Europe is trying to build an entire semiconductor ecosystem simultaneously, but without the unified political structure to support that ambition. So America sees semiconductors as a matter of survival. Europe sees semiconductor as a matter of industrial competitiveness. And that difference shapes everything. America drives decisions from Washington onwards. Europe negotiates decisions across 27 capitals. One system rewards speed, the other rewards consensus. Both have strengths, but only one is suited to rapid industrial mobilization. Now let's break the Europe's three biggest weak points. Europe's challenges can be summed up in three uncomfortable truths. First, Europe does not control the raw material it needs. Gallium, germanium, rare earth metals, and high-purity chemicals. Most come from China. A single export restriction can cripple European chipmaking overnight. Second, Europe lacks advanced packaging. Even chips built in Europe often must be traveling thousands of kilometers to Asia to be assembled, stacked, bonded, integrated, tested. And in the era of chiplets and 3D architectures, packaging is as important as the wafer itself. And third, Europe still depends on companies it doesn't fully own. It's an Xperia situation. A Dutch company with Chinese ownership exposed how fragile Europe's mature node supply chain truly is. Automotive and industrial sectors rely on Xperia components every single day. When politics tightened, supply chain shook. Europe's semiconductor future doesn't just depend on funding, it depends on control. And right now, this control is limited. So, and finally, who will lead in the future? So, where does this leave the US and Europe in the global semiconductor race? The United States is positioning itself as a backbone of AI manufacturing. It has the design companies, the data centers, the capital, and now the fabs and packaging infrastructure to support the next generation of AI chips. Europe is positioning itself as a backbone of chip-making tools and specialized technologies. Without SML, the world cannot manufacture leading-edge chips, and that gives Europe extraordinary geopolitical leverage. But that leverage doesn't automatically translate into manufacturing sovereignty. Europe's strength lies in the research excellence, equipment dominance, and specialized industrial semiconductors. America's strength lies in scale, speed, and strategic focus. Both are powerful, but only one is building the full stack capacity to lead the AI era end to end. So here's a final question. Is Europe building a semiconductor future? Or is it simplify funding as a part of the supply chain it already excels at? And can Europe realistically catch up to the United States that has tied semiconductors directly to the national security and AI dominance? I'd love to hear your thoughts. Tell me in the comments. If you enjoyed this special edition, hit like, subscribe, and share it with your network. And as always, stay curious, stay sharp, and stay chip aware.